Okay, so our strategy for items 20 and 21 left and right is going to be a top-down assembly. So in our three strategies, we've kind of seen that we have the bottom-up, build the parts, put them into an assembly. We really haven't gotten that far into the assemblies. Within the couple of assemblies that we've done, they've been pretty basic. We've had some multi-body parts where the handle or the weldment was kind of treated as a single item that had two parts, and we really haven't separated those out or done anything with them yet. And then we get into top-down assembly, which starts the conversation about external references. All right, so depending on what we're intending or what we're going to end up with, the reason that I want to tie all these together, it comes back to these really tight toleranced items. So that means that we're going to make the parts, we're going to assemble them, and then the final grind will be to establish those faces and hold those really tight tolerances. So within the top-down assembly, let's go ahead and pull that out of the way. We'll close that one. So far, we've been making parts and more parts. So let's go over into the assembly. And, I didn't really want to open anything. Was there start command, automatic browse when creating? No. So I'll turn that one off. And no, I'm not even really interested in bringing anything in. So let's say that we're jumping over a few steps here. This is going to introduce the concept kind of before we've gotten into the assembly, but our next step is to take all of these parts that we've created and start the assembly. So, a little bit cart before the horse, but we need these last couple of parts, and I would like them all related together. All right, so one of the things, let's bring this back then, is under the file structure. Let's see, is it that one? All right, so we had the handle, which was kind of our first introduction into the hand lever assembly, so it's items 7 and 8. So I'd like to do the same thing here and go ahead and create a new folder, and this will be, they're calling it the block. All right, so block slide it is. All right, so something that, if I can spell, makes sense. Block slide, and that gives me a file structure to where these files will be kind of separated or pulled out of the mix. And depending on how I choose to manage this, I'll have a specific location for that top-down assembly. All right, so one of the things with top-down assemblies, as soon as you open up the assembly, save it, name it. Don't need to do anything else. Save it and name it if your intent is to start tying these items together. So we created the folder, and we'll go with 20-21. We'll keep it with the block slide, and we'll go ahead and put in the LR. All right, so not sure of my naming convention, so I'm over-naming it. But that naming, it's going to take a little bit to change it. If I decide that I don't like that naming convention, I'm going to have to back out of it. Is a little more difficult. All right, so that puts us into a mode where we can start sketching. So there's such a thing as a layout. And one of the problems with layout is that in 2014, 2015, and I believe at least part of 2016, SolidWorks, that after I started sketching with layouts, at some point the layout would show me, but then when I needed it, it would disappear. So that was always a concern. The other thing is that the layout sketch is a 3D sketch. So we'll do that real quick as an envelope, and if it doesn't play out, or if it's still something that goes on in the background, it won't be any great loss. All right, so nope, didn't want a center. I want a corner rectangle. All right, and so Also, since I'm throwing all this fun new stuff at you, the 3D sketch. We are in a plane within a 3D sketch. And I can tell that I'm in that 3D sketch. Well, the layout is a 3D sketch. It's always a 3D sketch. If I double click and I go to draw a line, there is that floating red origin that we saw from the hole wizard when we selected 3D sketch. So to get back into the front plane, I double click on the front plane. It puts me into 2D sketch mode. And we're just going to draw the outside limits. So midpoint, I do want this to be centered. And the overall dimension was the 2.2515. 2515, too many numbers. And lower limit was 2.2510. And then the overall height was 2.25. So pretty much rectangular. Or square. Been a long day. Alright. So that gives us our starter shape. Alright, I'm not going to include the details until I verify that this generates the desired result. Alright, so the cube, or the shape, will end up being an overall of 6, where did I see that? 3.062 times 2, 6.625 on the upper left. So let's go ahead and fly this back in. So the 6.625, we've got this front shape. And really I'm just looking at creating that envelope volume in the layout. And so I'm not going to go back into the plane to sketch. We'll go ahead and hit Tab. I'm in the line command. Tab again rotates, and Tab again will rotate that coordinate system from the XY, the YZ to the ZX. And then I can start bringing off geometry. And I just have to be careful to obey the rules of the direction that I'm sketching, otherwise I'm throwing lines off at weird angles. So as long as I'm following that arrow or the vector rectangle that's being generated, I can't just say draw up, because that's actually putting it off at an angle in the plane that I'm sketching in. Alright, and then we'll bring that one back and kind of missed there, so I want that to be along Z. Okay, and if it doesn't want to be along Z, then we will pick out of it and let it do something different. The overall was the 6.625. We'll go back into the line command, and I'll generate the next rectangle. Alright, so same thing, I kind of overshot it, and so that one will be along Z as well. And then we can override some of the 3D sketching by connecting the dots. It will ignore the plane that I told it to sketch in as long as I'm going from one endpoint to the next. Then this goes to a long Y, and now I have the basic shape of my my envelope. All right, so it's in place. The only way that I know that there is a layout sketch is that it shows me the shape, which is the same shape at the layout. I click on it, it puts me back into the sketch in the front plane, and then I can click out of it. If I right click on the very top level, there is the layout, and then if I hide the layout, it goes away, and if I show the layout, it's there. So we'll save that one more time. And then on the front plane, we'll open up a sketch, and now we'll actually start putting in geometry. All right, so I want just the basic outside shape. And I should have just drawn a rectangle, gotten it over with. All right, so center rectangle to, well, nope, corner rectangle. And then these sides are going to be equal. All right. the distance between 1.687. Oh, that's to the bottom of the slot, so not quite. Let's go ahead and tie these together. Alright, so since this is still kind of a layout sketch, what did we have for thickness there? Okay, let's go ahead and fly that in so we can pick it up. Alright, so 1.62 from the top, and then across the bottom, maximum material condition would be 1.438. And even so, I'm going to stay with the maximum material condition, 1.438. And my assembly is obviously in 2 decimal places, so that'll make it a little interesting. We had the 1.625 from the top, and got an extra one there. Doesn't look like it was that thick. Oh, 2.125. Yep, I went 2.5. Alright, so I missed that one. So let's get out of it. And I'll go back in and I'll edit the layout. So let's try again. And then rebuild. When I edit sketch 1, and there is the problem with the layout. I've lost that layout into the background, and I can see it when I'm outside of the sketch, but any sketch that's tied to it, I now have a problem. Alright, so enhancement request number 3, or number 5, I don't know where I'm at. So getting back into that sketch, the layout disappears, and if I tell it to show the layout, it thinks it's already being shown. That doesn't do me any good. Alright, so at this point, my strategy is either something that doesn't follow the logic or the standard workflow. Alright, so I can pretty much ignore the layout. I'm okay with that. Hide the layout. We'll go back into sketch 1. And the 1.63, we will just take that coincident off, and that coincident off. It's showing me the previews in the background, so that's nice of it. And that coincident off. And I can tie those back together, make these collinear, and then we had an overall of the 2.125, and then the 1.63. Alright, and those two were equal length, which was fine, but in the process of removing the coincidences, I've lost the tight tolerance, the 2.515. Alright, so we're there, but I still have a little bit of an issue in the background if I'm going to rely on that layout. So on the other side of things, if I need to, and edit the layout, I'm still going to be able to get to it. I just can't relate anything else to it now. I've attached that very first sketch to it, and I'm done. One and done. Alright, so at that point, 2017 has not corrected my issues, so I'm still at the point of layouts have very specific, but I do not want to include all of this geometry in one layout. Okay, so I'm going to, as soon as I tie those sketches to it or start to build sketches onto my 3D sketch scaffolding, it's going to go away. Alright, so that gave me the side geometry, and alright, so let's do layout for the front. The right side then, pick that geometry, and we'll go from the origin up and out. Because we can project into that that sketch plane, I will make it coincident to the endpoint. We said that it was 6.625, and I'll go ahead and let's go ahead and bring one more out. Don't know if I'll need it, but it wouldn't be bad to have it. So coincident. And then we have those notches on the sides. So let's see, there's a 3. All right, so control 3 will bring the notch up and over, and then it has a radius of 0.25 and back up. All right, so 0.375 deep and 0.875 to the end, and a radius of 0.25. All right. The other thing that I would need or want is the locations of the holes. All right. So if I go center line, that looks like 0.25 off of the base, and then I'll just go ahead and put the points in place. Whether we do these as a hole wizard. 0.25 from each end, and then 3.062, 3.062, so that one should be at the midpoint. And then we'll add one driven dimension to see if it plays out. Alright, make this dimension driven, and 0.25 from each end as driven dimensions. Alright, so that gives me my sketch geometry. Alright, so what else was I missing? Oh, the notches in the end, so the relief on the slide geometry. And then the hole locations, not too worried about those. We can pick those up at the top, or I can go ahead and put them into the right side view. That would be okay. So we'll rename that one layout. On the right, we'll go ahead and edit. So location in that plane, and from the front was 1.25 back, and then 4.125 from the side. Okay, so we got the 3 connection points, the 2 hole location points, and oh yeah, the slide. So let's go ahead and edit. Go back to Control 1. So the nice thing about the 2D sketches, well, I didn't want the midpoint, or at least I don't think I wanted the midpoint. So we'll have to reattach that one. Let's go ahead with the center line, vertical, infinite length, and then I can just go ahead and mirror. And we'll mirror the entities. That was an interesting result. Oh, shifted from the origin. So that's tied back to the layout. Okay, so as I hover over those, it's telling me what it's connected to and where. Okay, let me out of that. Alright, so interesting result. Let's go ahead and make that the midpoint. Ah, nice. Alright, so that's already horizontal. Midpoint, horizontal. Alright, so strange, but not entirely unexpected. Double check the display delete relations. Don't see anything jumping out at me. Between the width, 1 and 11/16, 1.687. And the height is 375. And location. Alright, we're going to fly that in, let it zoom up a little bit. off of the base, 0.562 to the center of the slot. All right, so that's one of those cases I could either put in a center line or we can put in a point. And we'll go from the line up to the center point and locate. All right, so we're investing into creating that sketch because just like the layout in the parts, we're going to build additional parts off of these sketches, off of this layout. All right, so once again, we'll save. And previously, we would just insert components. We would take something that we already selected, and then the rest of our process, we will be doing insert components. But in this case, we're going to do a new part. And as soon as we create this new part, if we haven't saved this name to the way we want, it will be tied to assembly 1. It'll be assigned to whatever name we have given it. So template is part inch. I don't really like tying it to any specific plane, so I just escape. And I don't want it to put me into the part. The brackets here mean that we are in a virtual component. These parts will only exist inside of this file, inside of this assembly file, until I extract them. All right, so part 4, let's do item 20, the block. When I right-click and I edit item 20, we're going to edit the part in the context of the assembly. And this goes blue. We can see that we're editing. We have a lot of those sketch items. And I'm going to go ahead with a sketch on the front plane. And because I clicked out of that check mark or selecting a plane to be the front, it just defaults to the normal assembly geometry. Now I can tie to those sketches, and what this gives me is those two sketches, with or without the layout, gives me a single point of failure. If their majority of geometry exists in the front and the right, and or a top if it's needed, we didn't really need it here, I'm going to be able to go back and find any errors at this assembly level and make the corrections out of these sketches, and the majority of these parts with their features and their sketches will all be tied back to existing geometry in the layout front or the layout right. So features, extrude boss base, up to vertex, we'll take it to the endpoint. We go into the hole wizard. Those were quarter 20s. And it did not give us a depth, so up to us. S key, go into the hole wizard item, tapped hole. We're going to go back to the quarter 20, pick our position, go normal 2, and I have those 3 sketch points that I'm going to tie to and accept. Oh, that was a through all. Didn't exactly want to do through all. At least not 1 7/16 or so deep. So let's go back through the rest of the parameters and double check. So up to next, no. Blind in condition, 370, 120. Nah, that doesn't really make sense. How about restore defaults? All right, 0.5 and 0.75. That gives us 2 times the diameter. All right, so 2D on a quarter 20. That's a reasonable amount of engagement. All right, it means the holes will probably intersect at the center, but we're not required to tap all the way through. All right, even if I drill the hole all the way through, when I come over to tap it, I only have to tap from this side or only have to tap from this side a ½ inch deep, and that's going to hopefully improve my manufacturing process. All right, so we go ahead and accept. And did not see, or not seeing the cosmetic thread just yet. S key, same parameters. Go to positions, we'll go normal 2, and I'm going to pick the same 3 points and accept. And so yeah, it's showing the holes going all the way through. but when I get to the maybe we turn the cosmetic threads off. When I get to the cosmetic threads, they should only go in 1/2 inch. All right, one more. We have the drill, 2x drill and counterbore. So let's look at this. Counterbore is 218 deep for 1/4 by 1 Philister head cap screw. We already said that we were going over to socket head cap screws, and we'll use the hole wizard to set up for that counterbore. All right, so let's see, counterbore, and picking, we do not want a binding head. There's the Philister head if we decided to stay with it. We're going to go over to a socketed cap screw. Size is 1/4. Normal clearances up to next end condition. Let's go ahead and show the custom sizing. So 266 on the diameter, 437 on the counterbore diameter, and 0.25 deep. So a little bit deeper than what was called out. We don't have any thickness conditions there. And the 437 is a little on the large side. If we even went to a close fit, 257, it's going to stay at 437. A lot of times we'll reduce that to 406, 410, somewhere in there. Don't see it as being a huge issue. We'll go to the top view and pick the point and pick the point. All right, so those two go into location. I get out of the part. Everything goes from blue back to normal, and we have the geometry. Notice then that we have in that description, let me pull this out, we have our first dash greater than. All right, and that tells me that I have an external reference. All right, next part will be the left side. So under the insert component, new part, part inch. We go ahead and just pick somewhere or escape out of it. And item 21 left. All right, so 21 slide, and we will have a left. And then I could edit the part. Notice that the block now goes to transparency. We have it existing and we can pull geometry off of it, but I don't want anything existing going to that part, so I'm going to expand out my display and hide that information for now because I want everything tied to this sketch. All right, in the sketch then on the front plane, let's go ahead and convert entities, and then I can trim out. I'll go back over to trim. So all of my sketch tools are there, everything, but I am in the context of the assembly with my geometry. Features extrude. So at this rate, we invested a lot of time up front creating these sketches, getting the front and the right sketches in play. But the payoff is that now my parts are going to go reasonably quick. All right, so from the right side, selecting on the exterior, hitting the S key, we're going to go back to the counterbores for the 1/4-20. So counterbore, socketed cap screw, 1/4 inch, normal, up to next. Up to next is just within this part. We pick the same 3 sketch points, a little close to the edge. We haven't overrun it yet, so that may be a good case to measure the socketed cap screw and reduce those to 410 on the custom sizing, but for now, it's reasonable. I would expect a little deformation with the grind. That might still be an issue. All right, and then the last item here is to open up a sketch. I think it went to the, let's do a Control 8. Okay, it went to the right one. See if it's there. It goes. Not sure why it went select through the part. It might be one of my settings. All right, so not Control 1, Control 3. We'll drag the converted entities back, and then features, extrude cut, up to next. while we're through all. And we'll go ahead and accept. And then I can hide it. We do one more new part, hard edge, and this becomes, let's go ahead and click out of it, item 21, slide, and the right. All right. So one of the things that we can do, let's see, is it assembly? Component patterns, we can mirror components. That creates an external reference and also has a different strategy. Since the left and the right are mirrors of each other, I would consider that, but I have enough geometry that if for some reason these weren't going to be exact mirrors of each other, I have a condition to where I can make them fully individual. All right, so back into the front plane. Well, nope, we want to edit. Got to make sure that we're editing the part, that it goes into blue. Anything else that would be shown would be in transparency. Oh, I haven't, not sure why they're not in transparency. I am editing the part though because it's in blue. Maybe when we go into the sketch. So open up the sketch. No. All right, I'm not sure why they're not in transparency then. Pick our edges. Edit, convert entities. We'll go to trim. And accept, or we can just go ahead and extrude. Extrude boss base up to vertex. And that gives me the first geometry. Same thing that we did before, S key. And we'll go normal 2. We're still in the socketed cap screw, counterbore, go to positions. And because these are all being pulled off of the same 3 points in the layout sketch, very little chance, not an impossible chance, but very little chance that these will ever misalign. All right, they're all tied to the same 3 points. If those points move, all 3 of them move. All right, and then the same with the relief notch. And we're not selecting through the part. Yep. So I'm going to rotate over, convert the entities. Needed a normal 2. We'll bring that up. And features extrude cut up to next. All right. Go ahead and accept. We're back into the sketch. We can show the other 2 items. I'm through with the layouts, and we can hide. If this was much more complicated, or any more complicated, I would consider going to the display states again and adding a work in progress, adding a show me just the layout, show me just the parts, and being able to manipulate those as display states. All right. So at this point, we might as well go ahead and complete out the sub-assembly. And we'll go ahead and rebuild. All right, so that looks okay. Underneath our add-ins, we can go to the toolbox. The toolbox only exists inside of the assemblies. We're adding fasteners, we're adding hardware to the assembly, and then if we need to create something, we do it elsewhere. Okay, it's thinking about it. Thinking about it a little too hard. All right, so apparently first time I've loaded toolbox. I don't know, I had to do something. All right, so we're expanding out. We're going to close up the design library. Toolbox now has an arrow beside it. We're going to do ANSI inch. We're going to navigate down to, where did I see it? Bolts and screws. And then we are going to use socketed cap screws. So there's the socket heads. And we're just going to use the regular socketed cap screw. I drag it to the location. And it picks the size. I just need to verify the size. 1/4 28, not so much. 1/4 20, you'll find that it very often goes to the fine. And then the length, we have about, I didn't do the math or the measurement. We're not quite all the way through, but I'm suspecting we need to be a length of probably 0.75. We can come back and check it. So let's go normal 2. If it'll give me the display state, we'll go to hidden lines visible. And yeah, compared to 0.75 looks pretty good. Alright, so picking that edge, it adds the coincident and the concentric mate for me. So as I'm going through and I'm finding those edges, it's adding, and if for some reason it was needed to go the other way, I could hit the tab, and tab would reverse it. Well, not really. Okay, there are times where you would want to hit tab and if it didn't quite go in the way that you were expecting it to. Alright, so that completes our top-down assembly. We'll make sure to save all, rebuild and save, and then it comes up with this nice little warning: do you want to save internally or save externally? Right now, again, these only exist inside of this assembly. So at the point that I go, let's go back to File Explorer, I'm only going to see in this folder the assembly file. Everything's consumed, everything exists inside of the assembly. And if this was a purchase part and it had all of these items in it, I may just want to leave them virtual. I don't care about making the individual items or having them separate. So them living inside that virtual or living inside of the assembly is not a big deal. So if I tell it to save externally, which ultimately we will want to extract these 3 items and have them be a separate, so that the subassembly can be used and then detailed individually, we'll save externally. And same as assembly, so it's going to put it in the folder, block slide. Don't need to specify, we'll just go OK. And now when I look at the File Explorer, we have item 20 of the block, item 21 left and right. All right, so now these are individual, but when I open them, notice that each of these features has something, that external reference, pointing back to that assembly. That's how I know it's a top-down assembly. All right, so something in the sketch is tied somewhere else. If I open that sketch, no dimensions. And horizontal, let's see what we get. Coincident with an external reference. Coincident with an external reference. No dimensions. All of the dimensions tie back to those assembly sketches as hopefully a single point of failure. And no, we don't need to save. No, well, should have just gone ahead and let it. And then that brings up another real quick point. The alternative is I draw this block. I draw this block and I relate all of these holes to this block. And then I draw this block and I relate all the holes to this block. And I'm stacking up all of those relations from component to component to component to component. And then I find out, oh, this isn't the component that I needed. Or this component isn't available. And I have to extract it. And it's at the base of my pyramid. It's at the base of all those external references. And all of a sudden I have a series of errors that cascades through all of the rest of the parts. Ask me how I know this, because I've done it, or I've been a part of it. All right, and that's why I adopted the single point of failure, that if I have these layout sketches and it ties back to one place, the assembly, and to these 2 items, I may still make a complete mess of my top-down assembly, and have to go back and chase those dimensions, chase those errors, but I'm only looking in one place, not where does this one relate to this one, which relates to this one, which relates to this one, on down the line. So that being the case, the purpose of the top-down assembly, the purpose of the multi-body parts, is you have this speed element, that you're going to be able to build things faster and have more reliability at one level, but you're also assuming the risk at another level. So before you take on the top-down assembly, this is a really good starter piece with 3 items. One of the top-down assemblies that I built in industry, I want to say, was 30 to 35 components. And it became a giant calculator for manufacturing. And it was really convenient to stretch and shrink and come up with different size products. But it also came with the risk that if these external references were broken or corrupted, that the entire assembly could potentially fail, all right, or have to go back through and correct. All right, so there's a warning that comes with it. There is the promise of something that will go really fast after you put the effort into these sketches, and your layouts are created. On the other side, don't mess with the dash greater than external reference symbols. They can get really interesting. Notice that all of these are fixed too. I don't want to float these, because anytime I move one of these parts, it's going to snap right back to its location because it's tied to the sketch. Inside of the part, I may be moving it all around the inside of the part and losing its mind in relation to the origin, but it will always try to get back to the assembly in the same orientation. So there is a perceptual problem as well as the workflow and the logic. All right, so I'm not saying don't use it, but be prepared that you're operating at a higher level, and the higher you get into that level, the more complexity you're creating. So is the speed worth the trade-off for the complexity?